Okay, so now let's look at a couple of new questions here. First one, fill in the missing entry of the given matrix. Assume that as matrix, the equation holds for all values of the variables here. Okay, so this should be straightforward, right? So as you can see, it's going to be 2, 0, 1, negative 4, 5, negative 1, 9, 0, 3, right? So that's how do we do this, right? So yeah, simple. 2, same thing. So if you do so T is a linear transformation by finding a matrix that implements this mapping. So we're looking for AX such that, this is true, x1 plus x2 minus x3 plus x4, and x1 plus x2, 2x3 plus 3x2, and x3 plus x4, right? So of course x here. The matrix A is going to be what? It's going to be 1, 1, 0, 0, 1, 1, 3, 0, negative 1, 0, 2, 1, and 1, 0, 0, 1. Okay, so just simple stuff. Same logic for this one. We're looking for so this is a 3x1 minus 4x2, x1 plus x2, we have 0, x2 here, right? So we're looking for right times x1, x2 is here. So you see this is a 4 by 1, right? So this is a 2 by 1. So this is going to be a 4 by 2, right? This is going to be a 4 by 2. So the matrix is going to be what? It's going to be 3, 1, 0, 0. And then negative 4, 1, 0, 1. Okay. That's it. Simple. For C, doing a linear transformation such that this is true. So actually, as I find the x, this is simple. So it's 2x1 plus x2 equals 3, and then 4x1 plus 5x2 equals 8. Right, so you can just solve that. So you can do 4x1 plus 2x2 equals 6. So just times 2 here, do a difference. Turns out 3x2 equals 2. x2 is going to be 2 over 3. And so 2x1 equals 3 minus 3 over 2, which is 7 over 3. So x1 equals 7 over 6. Okay, so the x looking for here is 7 over 6 and 2 over 3. Okay, so it's simple. Number 3, finding the inverse and then to doing this multiplication. If you do left multiplication, so which we know what is going on, right? So with this 1, 1, 1, 1, 2, 3, 1, 4, 5. You see, this is if we do a left multiplication, b times a. This is a identity matrix, but on top of that, you use row 1 times 2, use row 2 times 3, row 3 times 5. If you do a left multiplication, it's exactly the same thing. You just did times 2 times row 1, 3 times row 2, 3, 6, 9, 5 times 5, 20, 25. Okay, so that's super simple. If you do the random multiplication here, to 0, 0, 0, 3, 0, 0, 0, 5, and then as you can see here is what you're going to do is so it's basically as you can see here is you're going to use your so you can calculate it here. That are going to give you is going to be a 2, 2, 2 here, and it's 3, 6, and 12 here, and also you're going to have it's 5, 15, and then 25. Okay, so how do we get this? Don't you agree that basically it's you use this the number of 2 here, and then do you see you perform it on the corresponding column, right? Multiply by 3, perform on the second column, give you this one, and then perform this onto times 5, give you the third column. So you can see if we have this multiplication on this identity matrix, if it's a left multiplication, so the row operation you act on the corresponding rows, you're going to exactly apply on the same row, right? But if you come back to a right multiplication here, and then you can think about it in terms of the columns multiplication, because you can think about it this as I multiply 2 for the first column, so you're going to act to the first column for this matrix here. That will give you the corresponding value. Same logic for the second column and the third column. So in other words, if you do the left multiplication here, you perform on terms of the rows. If you do the right multiplication here, you will see that you're gonna do the perform in terms of the corresponding columns. Okay, so that's something you can really think about here. So regarding to its inverse, we have talked about this a couple of times. So right, so you can do 1, 1, 1, 1, 2, 3, 1, 4, 5, 0, 1, 0, 0, 0, 1. And then as long as you can transform this part in terms of a identity matrix, then this side is going to be the inverse. So you can check the work. Okay, so that's the inverse. I'm not going to calculate it. You can do by yourself. Okay. 4 and 5 are also two simple ones. To find the inverse of this, so this is, since this is a 2 by 2, so we know that it's 1 over the determinant, a times -3, 8, -3, 7, right? So determinant of a, it's -24 minus -21, so this gives us is -3. So you just replace this, and then we should be good to go. Okay, so it's -1 over 3 to all this. Okay, so you can do it 1, 1, -7 over 3, -8 over 3. Okay, that's it. And so last one, so given this, find the second and third column of this A inverse without computing the first column. So for this one here, so -2, -7, -9, 2, 5, 6, 1, 3, 6. You see, when we're trying to find its inverse, we kind of like stacked the 3 by 3 identity matrix. But keep in mind that the row operation that we perform such that we're going to make this part into the identity is going to be exactly the same thing for the corresponding for each column here. So in other words, if we only look at the second and the third column here, so we can just stack the second and the third identity matrix, which is going to be 0, 1, 0 and 0, 0, 1 here, right? So that's the second and third one. So as long as you can perform this part into this identity matrix, and then the resulting of this part is going to be what you get. Okay, that's going to be what you get. So I think that's really the main idea about this. So let me quickly do one more thing, and then I'm gonna if you have questions here, I'm gonna provide you the answer in a minute, but if you have any questions, this is we already conducted this rule operation many times, right? So let's see. Yeah, so it's inverse. You will see that when you do that 1 0 0 0 1 0 0 0 1. So the second and third column, it gonna give it 1 -1, and then 3 -6 4. Okay, so you can verify your answers, okay, by yourself. And if you have questions, you can message. Okay, so thanks for the watching. I'll stop here.